In the last lesson, we learned how to solve a homogeneous linear differential equation with constant coefficients. In this lesson, we're going to start looking at how to solve non-homogeneous linear equations with constant coefficients. So that is an equation of the form So recall, to solve an equation of this form, we must first find the complementary function y sub c. And this is done using the techniques of the previous lesson. Then we must find any particular solution y sub p. It is this step here that we focus on in this lesson and the next lesson. There are two methods. There's the method of undetermined coefficients, which is what we are examining here. And then there's also the method of variation of parameters, which we'll look at next time. Once we have these two functions, then the general solution, remember, is y of x equals the complementary plus the particular. So to use the method of undetermined coefficients, we conjecture about the form of y sub p that is motivated by the kinds of functions that make up the g of x. Now, this method is limited to linear differential equations with constant coefficients and where g of x is a linear combination of the following functions: a polynomial function p of x of the form a sub nx to the n plus a sub n minus 1 x to the n minus 1 a1x plus a naught. A polynomial times the exponential function. The exponential function times cosine, and the exponential function times sine. Now, this set of functions have the unique property that the derivative of some products of these functions are also sums and products of these functions. So it would seem reasonable to assume that y sub p has the same exact form as g of x. And we will see how to do this, or how to set it up, in two examples. We will now solve the differential equation y double prime minus 9y prime plus 14y is equal to 3x squared minus 5 sine of 2x plus 8x e to the 6x. So the first thing that we need to do is find the complementary function. So we're going to do this, we solve the differential equation y double prime minus 9y prime plus 14y is equal to 0. And of course we did this in the last lecture. We need to find the auxiliary equation and then solve for m. So we get that m1 is equal to 2 and m2 is equal to 7. So the complementary function is c1 e to the 2x plus c2 e to the 7x. Now we'll just store this in the back of our minds for now, because now we need to find y sub p. So to do this, we make note of our g of x. And we notice that g of x is actually the sum of 3 functions. We have a polynomial, we have a trig, and we have a polynomial times an exponential. We can thus use the principle of superposition and find 3 particular solutions. So the first particular solution is going to be based off of the 3x squared. So that's a polynomial of degree 2. So y sub p1 will be a polynomial of degree 2. The second particular solution will be based off of this trig function, 5 sine of 2x. So yp2 would have to be a trig function. Now, the derivative of cosine is sine. So our particular solution has to be a linear combination of sines and cosines. So it's going to have the form e times the cosine of 2x plus f times the sine of 2x. Our third particular solution is going to be based off of the polynomial times an exponential. So that means that our third particular solution would have to be a polynomial times an exponential, specifically a first degree polynomial times the exponential. So I'll have to have the form e to the 6x times gx plus h, which can be written as gx e to the 6x plus h e to the 6x. Our final particular solution will be the sum of these 3. So what we have to do is we have to determine the coefficients a, b, c, e, f, g, and h, hence the name undetermined coefficients. We're going to tackle each of these 3 individually, and then at the end we will just take the sum. So let's start with y sub p1. So we take the general form yp1 take its derivative, and take its second derivative. We now take these values and plug them in to the differential equation, except we're only going to consider this equals 3x squared part. So if we plug it in, we will get 2a minus 9 times 2ax plus b plus 14 times ax squared plus bx plus c. All right, so we're going to get 2a minus 18ax minus 9b plus 14ax squared plus 14bx plus 14c. What I'm going to do now is I'm going to group all of my terms together. So I'm going to group all of my x squareds together, all of my x's together, and then all of the constants together. So we're going to have our coefficient of x squared is 14a. Our coefficient of x is negative 18a plus 14b. And then our constant will be 2a minus 9b plus 14c. And this has to equal 3x squared. We're now going to use coefficient comparison. So the only way that the left-hand side equals the right-hand side is if the corresponding coefficients are equal. So what I'm going to do is I'm going to add plus 0x plus 0 to the right-hand side, and I'm only doing this to make it easier to see the comparisons. If we compare coefficients, we'll get the system of equations. 14a is equal to 0. Is equal to 3. Right? These are the x squared coefficients. Negative 18a plus 14b is equal to 0. Those are the x coefficients. And then 2a minus 9b plus 14c is equal to 0. And those are the constants, or the x to the 0 coefficients. There are several methods of solving a system of linear equations. This is a fairly simple system to solve. We'll get a is equal to 3/14, b is equal to 27 over 98, and c is equal to 201 over 1372. Therefore, our first particular solution is 3 over 14 x squared plus 27 over 98x plus 201 over 1372. So again, we'll just kind of store that for right now. To find yp2, we do the same thing. So yp2 had the form e cosine of 2x plus f sine of 2x. So the derivative would be negative 2e sine 2x plus 2f cosine 2x. And the second derivative is negative 4e cosine 2x minus 4f sine of 2x. And we'll plug these back into the differential equation. Except it's only going to equal this negative 5 sine 2x. Okay. So we wind up with negative 4e cosine of 2x minus 4f sine of 2x minus 9 times negative 2e sine of 2x plus 2f cosine of 2x plus 14 e cosine of 2x plus f sine of 2x. Distribute everything through, so we get negative 4e cosine 2x minus 4f sine 2x plus 18e sine 2x minus 18f cosine 2x plus 14e cosine 2x plus 14f sine 2x. Just as we did with the first one, I'm going to group terms together. So I'm going to group all of my cosine terms together and all of my sine terms together. So for cosine, we're going to have negative 4e minus 18f plus 14e. And then for sine, we have negative 4f plus 18e plus 14f. This will give us 10e minus 18f for cosine and 18e plus 10f for sine. And this has to equal negative 5 sine of 2x. So we once again will use coefficient comparison. So 10e minus 18f has to equal 0. And 18e plus 10f has to equal negative 5. This first equation is the cosine 2x. The second equation is the sine 2x, because I can add a plus 0 cosine 2x. Again, this is a system of equations. When you solve it, we get e is equal to negative 45 over 212, and f is equal to negative 25 over 212. So our second particular solution is negative 45 over 212 cosine of 2x minus 25 over 212 sine of 2x. And again, we will just store this. So finally, we need to do yp3. So yp3 had the form gxe to the 6x plus he to the 6x. So first derivative will give us first times derivative the second. So we're going to get 6gxe to the 6x plus ge to the 6x plus 6he to the 6x. Second derivative, 36gxe to the 6x plus 6ge to the 6x plus 6ge to the 6x plus 36he to the 6x, which can simplify to 36gxe to the 6x plus 12ge to the 6x plus 36he to the 6x. We once again plug these values into the differential equation. Except now it's only going to be equal to this 8xe to the 6x. So we have 36gxe to the 6x plus 12ge to the 6x plus 36he to the 6x minus 9 times 6gxe to the 6x plus ge to the 6x plus 6he to the 6x plus 14 times gxe to the 6x plus he to the 6x. So all I did was distribute. We're now going to combine like terms again. So we want to group all of our xe to the 6x terms and then all of our e to the 6x terms. So for xe to the 6x, we're going to have 36g minus 54g plus 14g. For the e to the 6x, we have 12g plus 36h minus 9g minus 54h plus 14h. So 36, 14 is 50 minus 4, so we're going to have negative 4gxe to the 6x plus, so we have a 12g minus a 9g, that is 3g. 36h plus 14h is 50h minus 54 minus 4he to the 6x. And this must equal 8. x e to the 6x. And now we'll do coefficient comparison to get the system. Negative 4g is equal to 8, and 3g minus 4h is equal to 0. So this is our x e to the 6x. This is just our e to the 6x because I'm adding a 0e to the 6x. Solve this system, and we find that g is negative 2 and h is negative 3/2. So our third particular solution is negative 2x e to the 6x minus 3/2 e to the 6x. We now have all three particular solutions, so we can add them together. And we get our particular solution is 3/14 x squared plus 27 over 98x plus 201 over 1372 minus 45 over 212 cosine of 2x minus 25 over 212 sine 2x minus 2x e to the 6x minus 3/2 e to the 6x. We can now finally find our general solution by adding the complementary to the particular. And so y of x is c1 e to the 2x plus c2 e to the 7x plus this whole thing. And there is our general solution. We will now solve the differential equation. So again, the first thing we need to do is we need to find the complementary function, which is done by solving the homogeneous. If we solve this, we get m is negative 1, and then we get 0 3 times. So the complementary function is c1 e to the minus x plus c2 plus c3 e to the minus x. I'm sorry, that is not e to the minus x. That is x plus c4 x squared. we now need to find the particular. And we do this using the fact that g of x is 1 minus x squared e to the minus x. So g is the sum of two functions, a polynomial of degree 0 and a degree 2 polynomial times an exponential. So yp of 1 is a. However, the complementary already has a constant. So we would try ax. But the complementary also has that. So we would try ax squared. No, but the complementary also has that. So we actually take the first particular to be ax cubed. Yp2 would be a second degree polynomial times the exponential. However, constant times e to the negative x, we already have that in the complementary. So we take this to be e to the negative x times x, then times a second degree polynomial. And so this is bx cubed e to the negative x plus cx squared e to the negative x plus exe to the negative x. Just as we did before, we'll just take each particular solution individually, find the coefficients, and then add them together at the end. So we start with yp1, which had the form ax cubed. Now, since we're going to be plugging these into the differential equation, and the differential equation only involves the third and fourth derivatives, that is all we need to find. The third derivative is 6a, and the fourth derivative is 0. So we plug these in, so we get 0 plus 6a. This has to equal 1, which very obviously means that a is a sixth. So our first particular solution is a sixth x cubed. We now need to find yp2. So this had the form bx cubed e to the negative x plus cx squared e to the negative x plus exe to the negative x. Again, we only need the third and fourth derivatives. So the third derivative is negative bx cubed e to the negative x plus 9bx squared e to the negative x minus cx squared e to the negative x minus 18bx e to the minus x plus 6cx e to the minus x minus exe to the minus x plus 6be to the minus x minus 6ce to the minus x plus 3e to the minus x. The fourth derivative is bx cubed e to the minus x minus 12b x squared e to the minus x plus cx squared e to the minus x plus 36b x e to the minus x minus 8cx e to the minus x plus ex e to the minus x minus 24b e to the minus x plus 12c e to the minus x minus 4e e to the minus x. We now have to plug this into the differential equation. I'll leave all the simplification to you. So you just need to verify that once you do that, you simplify and group like terms together. We will get negative 3b x squared e to the minus x plus negative 18b minus 2c x e to the minus x plus negative 18b plus 6c minus e to the minus x. And then, of course, that has to equal negative x squared e to the negative x. This will give us the system. Negative 3b is equal to 0. 18b minus 2c is equal to 0. And negative 18b plus 6c minus e is equal to 0. I'm sorry, this negative 3b should be equal to minus 1. This will give us the solution. b is equal to a third, c is equal to 3, and e is equal to 12. So that our second particular solution is of the form a third x cubed e to the minus x plus 3x squared e to the minus x plus e x e to the minus x. Adding these together, this one and that, we get our final particular solution to be a sixth x cubed plus a third x cubed e to the minus x plus 3x squared e to the minus x plus 12x e to the minus x. And so our general solution to this differential equation, y of x equals c1 e to the minus x plus c2 plus c3x plus c4x squared plus 1/6 x cubed plus a third x cubed e to the minus x plus 3x squared e to the minus x plus 12x e to the minus x. So this method is not particularly difficult. However, it is rather tedious. Also, there are restrictions on it, particularly the restriction of the form of our g of x. That concludes this lesson. I hope you've learned something, and we will see you in the next one.